Whiteboard in a few videos. I'm getting some equipment so that it looks a lot better. I know that was a little hard to read last time, but I did see a cool article posted by Philip Volette, or a cool link to a Git repository. Knowledge graph embedding is a great field of study on predicting values in knowledge graphs. Now, if you go to this link, you might not see why that's such a big deal. In particular, this libkge is a framework for uh, parameter tuning and hyperparameter tuning around knowledge graph embedding, which makes it even harder to appreciate with all that jargon. Then, if you go look it up, so now we're going to go make it more and more difficult, you end up getting articles like this. So this is a survey of knowledge graph embedding, and all you get is a bunch of math and maybe a diagram. Oh, and here's something called a hyperplane. Wow, what on earth is happening? Well, a knowledge graph is, as they say right here at the beginning, and this is a little tip on reading these papers. So the knowledge graph itself is just a head entity, a relation, and a tail entity. So the line is the important part of a knowledge graph, not the nodes. The nodes just represent a connection between those lines. So, for example, of a head entity, and they use the example of movies and their directors. Alfred Hitchcock is the director of Psycho. So we have Alfred Hitchcock has some relationship with the movie Psycho. You'd act in it, direct in it, etc., watch it, whatever that may be. So taking that simple idea of having a head, a relationship, and a tail, we can build giant graphs that work better than a traditional relational database, much better than a giant spreadsheet dictating all of these things. It creates a knowledge graph, which lets us use the mathematics of topology on information. I've been a big fan of these for years. You can ask anybody that's worked with me. The mathematics behind knowledge graph embedding, or the idea of knowledge graph embedding, is that given the information within an existing knowledge graph, we can predict new relationships, new values, or predict some outcome, like a net promoter score or propensity to purchase. The predictions like propensity to purchase are just normal mathematics when we decompose that knowledge graph into something more traditional, like a regular matrix. I'm not going to talk about those. Knowledge graph embedding is about predicting new values given existing values, new values for the graph, new tail values, if you will. And there's two large, sorry, I didn't mean to scroll that far down. There they are. So there's two large embedding techniques also listed in this particular paper. This is behind a paywall, I'm sorry, but this is the important part about it anyway. Translational distance models and semantic matching models. Translational distance model just creates a mathematical equation creating a cost function, a scoring function between a head and the relationship and the given tails. You can extend that to a giant graph, but you're going to have to kind of exhaust all the values of the graph in order to create a score for a given head and relationship to the tail. But that's the gist of this. You're doing a big equation just on a scoring function on the frequency of those values as they appear together. That gets into a lot of complicated looking matrix notation. The semantic scoring models are derivations that we'll see of like latent derelict allocation or even simple word devec. You create a matrix representation of the terms contained in your head and tail and relationship, and then you apply matrix operations in order to calculate a similar score. Nothing you need to worry too much about. Some of them are faster than others. Why don't you need to worry about those? Because we predominantly use neural networks to do this now. So yes, most of our business applications, we can comfortably black box these. It's more about how fast they work. Once again, head, relationship, tail, they pass through some hidden layer translation, and then you have a predicted value in the output. So that is knowledge graph embedding. Back to the business application of it, you see me use these all the time. If you look at my case studies, if you talk to me at a business sense at all, you'll see that they'll be all over the place. That's why I use, even from the accounting framework, RIA, resources uh, is resources, events, actors. So we have our data resources, our actors within those resources, and the events as they interface. That is a knowledge graph. We can start extending this right away into a data model, and we can already start embedding process for some of our business rules. That's what you see here in this case study. Go ahead on my site and read it if you want, but I have a lot of these. It's a great framework to work from. You can even go so far as to create interactive knowledge graphs. I've done this for a few clients in Neo4j just because it has a great interface of Cypher and the Neo4j console. You can try this out yourself. Go to Neo4j, launch a sandbox. And this is an example very similar to what they had in that scientific paper where you have your movies and then you can see directed by, acted in, etc. So we can see the Wachowskis, and then we can look at the movies that they've directed. We can look at Matrix Revolution. We can see Keanu Reeves, and then we can see the actors that all work together in there. So you can quickly see that it's a great way to explore. Imagine all the things that you can do if this was in a graphical CRM where you can map your customers to your products, not just from a visual sense, of course, that would get overwhelming, but from a mathematics sense as well. You can create propensity to score or propensity to purchase models easily. You can look at how many hops they had through customer service. You can even do things extending this, and I've done this before, where you have their behavior on the website and the media a customer was exposed to prior to their purchase. So you can see their entire map, and you can actually assign a site and a media value to the sale. So yes, knowledge graphs, incredibly powerful. I'd love to hear about how you guys have used them in practice, or if you probably use them, just not put them into data, just wrote them on a whiteboard. But yeah, I'd love to hear about your experience, or if you have any questions, feel free to let me know. Thanks.